Welcome students. Today we are discuss about the unit number 1 fundamental of cellular communication, and we are discuss the first topic basic cellular concept and cellular system. Student will be learn the following objective from this lecture: cellular communication standard 1G, 2G and 3G. Use full terms regarding the mobile communications. First generation, okay, 1G, second generation 2G, third generation 3G, fourth generation 4G, and basic cellular concepts. Now we are discuss the comparison between all our generation 1G, 2G, 2.5G, 3G, and 4G. Okay, so we are discuss with start deployment. So 1G are start with 1970 to 1984. 2G are start with in 1980 to 1991. 2.5G is start with in 1985 to the 1999, and 3G is invented in 1990 to 2002, and 4G is invented in 2000 and to the 2006. The data bandwidth in 1G is 1.9 kbps, in a 2G 14.4 kbps, 2.5G is also SAM 14.4 kbps, 3G in a 2 mbps, and in a 4G 200 mbps. The standards, okay, in 1G is AMPS, in a 2G TDMA time division multiplexing, CDMA code division multiplexing, and GSM. 2.5G is GPRS age, okay, then 1X RTT, and 3G, okay, WCDMA and CDMA 2000. In 4G single unified standards. Technology, analog cellular technology are there. In a 2G digital cellular technology, in 2.5G digital cellular technology is there. In a 3G, okay, broadband bandwidth CDMA IP technology is there, and in a 4G unified IP and seamless combination of broadband LAN, WAN, MAN and WLAN. Service mobile telephone in a 2G digital voice and short messaging, okay, in a 2.5G higher capacity packetization, in a 3G integrated high quality audio video and data, and in a 4G the dynamic information access, okay, wearable device. Multiplexing, so in a 1G FDMA is there, frequency division multiplexing are there. In a 2G TDMA and CDMA time division and code division multiplexing. 2.5G TDMA and CDMA. In a 3G CDMA technology is there, okay, I mean multiplexing is there. In a 4G CDMA, okay, code division multiplexing is available. Switching, so in a 1G the circuit switching are there. In a 2G SAM circuit switching is there. In a 2.5G circuit for the access the network air interface packet for the core and network and data. In a 3G the packet accept the circuit for air interface, and 4G all the packets. Core network, so in a 1G PSTN, okay, public switching telephone network. In a 2G PSTN, okay, 2.5G in a 2 PSTN and packet network, 3G packet network, and 4G is internet. Hands off, okay, so in a 1G the horizontal, in a 2G is also horizontal, in a 2.5G horizontal, in a 3G horizontal, and 4G is horizontal as well as vertical. Useful terms: base station, a fixed station which located at the center edge coverage area. It is also called the BTS, base trans receiver station. Mobile station, a handheld personal unit which communicate with base station, okay, and it is also called MS. Mobile phone, our mobile instrument is called mobile station. BSC, base station controller, okay, so it is control the number of BTS. Channel, for mobile communication the channel is a pair of frequencies for signal transmission. There are two types of channel for GSM: voice channel and voice and voice channel are used for the voice and data, and another is control channel to transmission of the network management information and channel control information. Forward channel, a radio channel used by the base station to communicate with mobile phone on downlink. Reverse channel, a radio channel used by mobile station to communicate with base station on a uplink. Okay, and mobile station to base station means our mobile instrument to base station connectivity is called, okay, uplink. Now we are discuss about the specification of our all the generations. Now we are discuss about the first generation 1G. So 1G is an analog cellular or AMPS advanced mobile phone service. Operating frequency range is 824 MHz to 894 MHz. Uplink frequency range is 825 MHz to 845 MHz, and the downlink frequency is 870 megahertz to 819 megahertz. Second generation 2G, the digital voice and low speed data, frequency band at 900 megahertz. Uplink frequency range is 890 megahertz to 915 megahertz. Downlink frequency 935 megahertz to 960 megahertz. The modulation techniques are used: GMSK, DPSK, fixed frequency assignment, support in international roaming, ability to support the handheld instruments. Third generation, use the, okay, win band, okay, use the smart antenna, support the multimedia service, permanent wave connection at 2 Mbps, HSPDA, high speed packet data access, wide area wireless voice telephony and video calls. Application of 3G, internet, email, web browser, data sharing, SMS, MMS, GPS, VoIP, Bluetooth, video conferencing, global roaming without change mobile instruments. Types of antenna used in our GSM. Okay, there are two types of antenna: omnidirectional antenna and sectorized antenna. Okay, so as shown in figure, okay, omnidirectional antenna is radiate in all the directions. Okay, the energy is radiate in all the direction, but the sectorized antenna, okay, is direct radiate the energy in particular direction. The omnidirectional antenna is radiate and receive the equal well in all the direction. It is also called the non-directional antenna because it does not favor any particular direction. This antenna is built using the metallic bar. So as shown in figure, okay, the omnidirectional antenna is shown in figure. Now the sectorized antenna, by focusing the beam in a more focused area, offers the greater range and throughput with less energy. Many operators will use the sector and antenna cover the 360-degree service area rather than the use the omnidirectional antenna. And omnidirectional and due to the superior performance and sector antenna is over the omnidirectional antenna. In sectorized cell, it can be either edge excited or center excited. In center excited cell, it can be 3 into 120 degree and 6 into 6 degree sector are there, while in a edge excited, and the BTS is located at the edge of the cell and provide the coverage to multiple 3 cells. So as shown in figure, okay, so the sectorized antenna are there. Okay, so suppose that there are 3 antenna is there, so 120, 120 and 120 is covering the total 360-degree. So advantage of the sectorized antenna: more power utilization, more user can access the channel, and disadvantage is need more antenna to cover one cell, and high cost. Basic cellular concept and cellular system. Okay, the definition of cell. So cell is a formally defined as the area where in the use radio communication resources by the MS, okay, mobile station, is controlled by BTS. The size and shape of the cell and the amount of resources allocated to each cell. The performance of the system depends on the given number of users, average frequency of the calls begin made, average duration of the call time, and so on. So as shown in figure, okay, so the hexagon shape is called the cell, and each cell is having its own base station. So in a yellow line, okay, its own base station is there, okay, and there are our instrument are connected with the base station using the uplink and downlink. Okay, now cell and cluster. Okay, so the cell is having the different shape is theirs. Okay, so as shown in figure, the circle shape is there. Okay, uneven shape is there, hexagon, square, and triangular. Okay, so which one is best? So we are discuss in cellular communication we use the hexagon to represent the cell area. So in a rural area the population density is low and the cell area is kept larger. Build up the area population density is larger, cell is small. Now cell shape. So the first cell is nothing but in a square shape. Okay, but what are the drawback of the square? So it is cover the less area. Now in a, okay, in a second one is triangle shape is there. Okay, so here is also same issue is there, it is covering the less area. So now we are discuss about the hexagonal shape. So why we choose the hexagon? Because of the it is covering the more area and there is a no any overlapping issue is there. So but when we choose the our cell shape is in a circle, so what are the issues? So in a first figure see the whenever all the three cell are meet together, so non coverage area is available over there, and when all the three cell are overlap to each other, okay, so the overlapping area is there. Okay, so at that particular area, so we are not okay, I mean our user is not receiving the any kind of signals over there. Types of cells. Okay, so macro cell. So macro cell is provide the largest area of the coverage within the mobile network. The size of macro cell vary from 3 to 35 kilometer in city area where the traffic is very high. The size of the macro cell are near 3 kilometer within the low power transmitter. When in a rural area, the size of macro cell is, can be up to 35 kilometer within the high power. Okay, so in a macro cell in a city, the area is covering 3 kilometers because the high population is there and traffic is very high. But in a rural area the size of the macro cell is up to 35 kilometer because the number of subscriber is less. Microcell. The size of the microcell range from zero point 0.1 to 1 kilometer located on top of the tall building use very high traffic. Okay, so it is used with the small coverage with low power transmission. Picocell. The picocell are generally used to covering the very small area such as particular area of buildings or possibly tunnels where the coverage from the large cell in the cellular system is not possible. Okay, so we are not covering the more area with the picocell. So picocell is used to specific area. Selectivity cell. Sometimes the cell term as a selectivity cell may be used where the fully 360-degree coverage is not required. Then they may be used to fill in a hole in the coverage in a cellular system or address a problem such as a entrance to the in a tunnel. So selectivity cell is basically used in a specific area. okay, at which we don't require the 360 coverage, but we require the specific degree or specific area. We require the coverage in specific area or specific degree. That time selectivity cell are used, just like in a tunnel. Okay. Umbrella cell, a mobile crossing the macro cell high speed produce a increase rate of the hands off among the neighboring cell. To solve this problem, and the concept of the umbrella cell is introduced. Basically the umbrella cell is, okay, is basically used to covering the our hands off handover process. Okay, and umbrella cell cover the several macro cell. Okay, and the power level inside the umbrella cell is greater than individual power level used in a macro cell. So number of macro cell are cascade connected together or and make the one umbrella cell. Okay, and which is covering the more area. Okay, and basically the umbrella cell is coming into picture whenever the our subscriber are change the one place to another place, or hand offs or handover is required. When the when the transit speed of the mobile is so high, and the mobile handed over to the umbrella cell, and the mobile will then stay longer in a SAM cell. This will be reduce the number of hands off and the work of the network. Okay, suppose the macro cell is there, okay, and our subscriber are changed the one cell to another cell. Okay, so many hands off are required. So the best way is we are using the umbrella cell, and which is covering, I mean, which is covering with the more micro cell. Okay, so suppose our subscriber are changed the one cell to another cell. Okay, so doesn't require the hands off. Okay, so when we don't need the hands off, means our drop chances of the drop call is very less. So as shown in figure, okay, so this is the umbrella cell is there, and which is, see figure, okay, just below the, it is covering the more macro cells. Okay, so more macro cell are covering covering with the umbrella cell. So umbrella cell is cover the very large area. Okay, thank you.